about lines and angles. So the first thing is if you look at this 3D figure, you can see that we have numerous parallel lines. And parallel lines, you know, are lines that extend forever and will never intersect. So for example, AB and DC, those are example of parallel lines. AB is also parallel to EF, and AB is parallel to GH. Those would be in a plane that crosses through the diagonal of this box. Okay? Skew lines are lines that never intersect, but they also are not parallel. So an example of skew lines would be AB and DH. They're not parallel, but they still will never touch because they're in different planes. DH will go up and down forever. AB goes side to side, but since they're on different planes, they'll never touch. So those are an example of skew lines. Another example would be EF and DH. Those are skew lines. EF and AD. EF and CG. All are examples of skew lines. Now EF and BF, they touch. Those intersect, so those would not be skew. And EF and HG, those are parallel because they're in the same plane, so those would not be skew. Your skew lines are lines that never intersect, but are also not parallel. Perpendicular lines are lines that intersect at a right angle. For example, EF and BF, those are perpendicular lines because if you looked at the box straight on, that would be a right angle. Now we're going to talk about angle pairs. So the first thing is this line, any line that... Now for this last activity, we want to look at this diagram and determine which transversal and which angle pair, because in this case there are 3 transversals and there are 3 different angle pairs. So for our first one, we're looking at angles 2, and it crosses through two parallel lines, or just 2 lines in general. This is called a transversal. So this highlighted region right here, that line, line T, is your transversal. When 2 lines are cut by a transversal, you wind up with angle pairs. So your first pair are corresponding angles. That means they're in the same spot in reference of the parallel lines. So angle 1 is in the top right corner of your parallel line, or your line being cut, and your transversal. 1 is in the same spot as angle 5, so angles 1 and 5 are corresponding angles. Another pair of corresponding angles would be angle 6 and angle 2. So angle 6 and angle 2 are corresponding angles. See if you can figure out other ones. Now, your alternate interior angles are on opposite sides of your transversal, and the term interior tells you that they are on the interior of your 2 lines that are being cut. So the interior is going to be everything between R and S, and alternate means they're going to be on alternate sides of your transversal T. So for example, angle 3 and angle 6, those are alternate interior angles. Another set of alternate interior angles would be angle 5 and angle 4. Those are your only 2 sets of alternate interior angles. The next one would be alternate exterior angles. Well, this is the exact same as alternate interior, except for being on the interior, they're now on the exterior. So your alternate exterior angles will be on alternate sides or opposite sides of the transversal T, and on the exterior on the outside of your 2 lines, S and R. So they'll be, one example would be angle 1 and angle 8. Those are alternate exterior angles. And then, in addition to those, we have angle 7 is an alternate exterior angle with angle 2. So angle 2 and angle 7. Again, those are your only 2 pairs of alternate exterior angles. Now the last one is talking about same side interior angles. And same side interior angles is exactly what it says. It can be called same side or consecutive, but it's on the same side of your transversal. So and it's on the inside of your two lines. So it's on the inside of R and S on the same side of T. Well, for example, 6 and 4, those would be same side interior angles. And those are also called consecutive interior angles. You'll see it written both ways. So angle 6 and angle 4, and you have one other set, which would be angle 3 and angle 5. Those would also be your same side interior angles. Okay? And angle 7. Okay? Well, those are on the two lines A and B, but both of them have C in common. So that means that our C is going to be our transversal because this line cuts through both of them, but then A and B cross through each one, okay? So your transversal is C because C is the line that both of those have in common. Your angle pair, you can see they are on opposite sides of your transversal, and they're both on the inside of your two lines. So those would be alternate interior angles. Another way to look at this is if you were to cover up this whole side, so if we were to take this, cover it up with this square, which let's fill it with a color. If you were to cover up this half of your problem, you can see two lines in your transversal. Much easier. I would just cover it up with your hand. Okay? So for the next one, we're looking at angle 8 and angle 12. Well, let's delete what we have here. With angle 8, we're looking at this angle right here. Angle 12 is right here. The line they have in common is line B. And so if we were to cover up the section of angles that has nothing to do with either one of those, we would cover up that top one. So you can see your two lines are lines A and C. So your transversal is transversal B. They're on the same side of our transversal, and they're in the same position. They're both on that southeast corner, okay? So those would be your corresponding angles. Now our last one. Our last one is talking about angles 3 and angles 9. Well, if we're looking at angles 3 and 9, we're looking at this angle right here and this one right here. So again, we could cover up this whole section in the bottom left of our page. The line they share is this line A, and now they're both on the same side of the transversal. They're both on this right side of the transversal. They're both on the inside of your two lines. And so while we know that transversal is transversal A, those would be same side interior or consecutive interior angles. Either one of those will work.